Please, please do.
Actually, there are two people who will lead this session. Dr. Oleg Abramov, in his capacity of academic secretary of the TRIZ Master Certification Council, he is responsible for all procedures of this today's defense of Dr. Yer. And I am responsible for the discussion, for moderating the presentation of Dr. Yer, and then question and answers. At the beginning, Oleg, could you please just remind the members of the council the procedure of today's session, and then I will give you just 3 minutes introductory.
We're already a little bit behind the schedule. Okay, but the procedure is, first of all, we start with the presentation of Dr. Yer. 25 minutes is allowed for this. Then scientific advisor is supposed to talk, and on behalf of him, I will read aloud his review. Then both opponents will talk up to 10 minutes each. And then there will be 20 minutes for questions and discussion. After that, we will vote. That's
okay. Actually, by the regulations, we have to vote for this program. Please, it will be easier if somebody will say that he is against. If nobody is against, it means that unanimously it's approved.
Hello, Robert. Robert is trying to reach us.
Okay.
He was trying to reach us on Skype for some reason.
Yeah.
Okay.
Maybe a problem is with Zoom.
Is anybody against the program?
Okay, let me speak to Robert. Hi, Robert.
Use Skype.
I will contact Robert, okay? I will do this and send him the link and so on.
Thank you.
So just carry on.
Okay.
So who's against the program?
I believe nobody.
Nobody.
Unanimously approved. And we also have to appoint the session secretary.
I would propose Alex Lubomirsky as a session secretary. His task will be easy because the session is recorded.
Is anybody against this candidature? Okay. Done, Alex, you are a secretary.
Yes.
Yeah. And okay, guys, to start the session in a traditional way, just very few words of introduction. First of all, hi everybody, it's nice to see you. Unfortunately, this time is virtually, but it's a pleasure to have all of you this session. We continue the tradition of TRIZ Master certification that was started by Henry Halschuler in 1998. He awarded 65 prominent TRIZ experts, TRIZ methodologists, trainers, practitioners with this title of TRIZ Master. He just appointed them. By that time, there was no procedure, no defense of this TRIZ Master title. And by that time, he was very heavily sick, and he passed away later that year, 1998. He personally asked me to continue this tradition, and it took several years. And in 2006, I proposed to establish a special procedure of TRIZ Master certification with TRIZ Master thesis defense. The certification became a part of International TRIZ Association system, 5-level certification system, and regulations were first developed in 2006 and approved by TRIZ board. And totally about 40 new TRIZ masters were awarded with this title after this. In 2012, under the require or how to say it, it was asked by prominent TRIZ master Voleslav Mitrofanov. He proposed to incorporate into TRIZ master defense not only people who develop new pieces of methodology in TRIZ, but also TRIZ practitioners. It was incorporated into the TRIZ master certification. And this process became more complicated. A lot of questions appeared. That's why this year the new regulations were developed and approved by International TRIZ Association board. There are 4 major changes in the regulations. First of all, it was 3 categories of TRIZ masters were established. They are equal in rights, but there are TRIZ masters researchers, TRIZ masters practitioners, and TRIZ masters trainers. Also, all candidates must defend a thesis, even practitioners and TRIZ trainers. This is new in the regulations. There are different requirements for these 3 categories, but as I said, all TRIZ masters are equal in rights. And also due to the fact that right now the only working language of International TRIZ Association is English. In the new regulations, it was stated that the candidate should provide his or her thesis only in English. He or she has rights to submit the thesis also on a native language, but is kind of optional. English version is mandatory. This year there were totally 5 applicants at the beginning of the process. 3 of them postponed their defense to the next year. And 1 candidate got 2 negative reviews from the opponents, and by the regulations, this person was not allowed to defend his thesis, and he will rework it and try to defend next year. That's why we have only 1 candidate today who overcame all these barriers and is ready to defend. Okay, now it's time for Dr. Yor to defend.
Simon?
Yep.
May I ask 2 questions regarding procedure? The first question is, according to our rules, all candidates should pass the pre-defense procedure, and only if they have positive recommendation from the pre-defense committee, they should present a thesis to us. Why our dear candidate didn't participate in pre-defense process?
Oleg, could you please answer this question? Oleg Abramov.
Simon, that was your decision.
Yeah, but actually in the regulations, okay, I will address the question. In the regulation, this pre-defense is mandatory for TRIZ researchers only. For the practitioners and trainers, it's not mandatory. It's recommended, but for this year, everything is online, and yeah, I've made a decision to skip, and the candidate will defend the practitioner.
Okay, No questions. And a second question, would you tell us what kind of contribution we should anticipate from TRIZ master practitioner? Because it is clear what we should anticipate from researchers. They should develop just a new piece of methodology. What kind of contribution should we get
Alex,
from practitioner?
I have a question to you. Did you read the regulations?
Yes, but would you please just wrap it up
Okay,
for all of us?
Okay, okay. The expected contribution is, first of all, the applicant needs to demonstrate that he is able to apply different TRIZ tools, apply in a good, in a high level, to tough practical tasks, which need to be approved by number of patents. So it has to make at least 10 different inventions. Practical tasks which he solved need to be important for mankind, which needs to be proven by the practical application of at least 3 inventions, which we can see in the products or technologies implemented in practice. And of course, the applicant, which I hope he will do in his defense, in his presentation, will need to show that these inventions were made using TRIZ tools, and the level of application of these tools should be high enough for a TRIZ master. I hope we will see that today.
Yeah, the idea is that the person is not just a prominent inventor,
yes,
but he or she is a TRIZ master, meaning that he effectively apply TRIZ to achieve this practical result.
Yes, yes.
Okay, thank you.
The last comment, I expect that it could be some problems with language for Dr. Yor. That's why I would ask the Professor Young that Professor Song, sorry, to help with translation.
If necessary.
Yeah, if necessary.
Yeah. As I know, Dr. Yo can speak English very well. That's why we don't have any problems.
Yeah.
Hopefully.
Okay.
Yeah.
Great.
So we can start.
Yes.
Do I understand correctly? So, Dr. Yo, the stage is yours. Please share your screen, and we're all ears.
We are all ears and eyes.
Yes. Nice. We cannot hear you.
Dr. Yo, you need to turn on the
You are muted,
microphone.
Dr. Yo. Yeah.
Unmute your microphone.
Turn on your
Dr.
mic.
여 박사님,
Okay, I'm sorry.
네.
Yeah. Now I'm turn on my mic, and first of all, I'd like to thank for everyone for coming in this presentation for my TRIZ master qualification. Now let me share my presentation material. So wait a minute, please. Okay, did you see that?
Yeah,
Do you see that?
There we go. Yeah.
Okay. Okay. The title of my thesis is Practical Application of TRIZ in Projects of Samsung Electronics. My name is Hyung-Seok Yeo. Just call me Yeo. Now, let's get this presentation started. My presentation consists of the same contents as you see. After introducing the purpose of this presentation, I'd like to briefly introduce myself. Then let me explain some of the TRIZ activities. TRIZ activities cover 3 main themes: R&D projects, patents, TRIZ practice. The objectives of this presentation are 3 main things. First, I'll tell you TRIZ various projects conducted in Samsung. Samsung's TRIZ tasks are actively doing in technology such as semiconductors, smartphones, and TVs. Today, I'm going to explain that interesting TRIZ activities in developing medical diagnosis system, IPCR, and healthcare monitoring devices and chip. The first task is based on TRIZ. The second, using function-oriented search. And the third, utilizing the multi-screen thinking and transweb evolution. Second, let's see how dynamic Samsung's TRIZ activities. Through this presentation, I'd like to show you my contribution to the development history of Samsung TRIZ. Now, let me introduce myself. I was certified as TRIZ level 4 on March this year. And I joined Samsung Advanced Institute of Technology in 1998 and carried out many R&D projects as a researcher. The list of R&D tasks that I was involved in is shown. Since 2009, I have worked at the VIP Center, Samsung's in-house consulting organization. And I'm still working as a TRIZ consultant with great people here. VIP stands for Value Innovation Program. This picture was taken before COVID-19 in the spring of 2018. It's me. You can see a list of R&D TRIZ projects that I have done since I learned TRIZ in 2003. By 2021, a total of 39 TRIZ projects have been completed. In today's presentation, I'd like to talk about these 3 projects. From now on, I'm going to explain my TRIZ activities, and this presentation is focused on R&D TRIZ projects. As you understand, I can't explain the entire contents of the project because of the time limit. To help you understand the first project, let me tell you the background of PCR and IPCR. PCR is an abbreviation for polymerase chain reaction. This is a technology to diagnose the disease or human identity by analyzing DNA sequences. It's being used recently to diagnose infection of COVID-19. IPCR is a technology that integrates independent functions such as biosample injection, analysis, diagnosis, and reporting into one system. This IPCR had been developed by SATE since 2008, and the final system was released in 2011. Now, let's begin with the first project. The problem is that stiction, kind of undesirable adhesion between the bulb seat and the PDMS layer, which is an elastic thin film. This stiction causes the fatal error in the opening action of the microbulb. In other words, the problem is that the microbulb does not open well. Through this functional analysis, you can see that there are some problems with this system, especially between microbulb seat and elastic film. The first problem is that if the contact between microbulb seat and the elastic film is being for a long time, the surface of microbulb seat becomes hard and sticky. And the deformed elastic film prevents the microbulb seat from guiding the microsample sufficiently. The second problem is that the objective lens has insufficient ability to adjust the focus of the light spot. This issue was intensively handled in the second project of IPCR. In the cause-effect chain analysis, 3 causes of bulb seat and elastic film problems have been released. This could be summarized as following two main problems. First, it has been confirmed that the opening is a problem rather than the closure of the micro valve. That's because the valve is almost always closed, and it opens for a moment only under some specific conditions. Second, the contact area of the elastic film and the valve seat should not be too wide. This slide shows the technical contradiction formulation. Also, the operating zone and operating time were analyzed. The operating time in the picture means the time when the valve opens and the valve starts to open the valve. And you can see the physical contradiction. It means that the valve should always work well, open and close. As you see, a total of 13 problems were derived based on the TRIZ process. And finally, idea verification experiments were conducted for number 1, 3, 9, and 11. Based on this table, I'll tell you about ideas number 1, 3, 9, and 11 that were finally tested. Concept solution number 1 was created using the inventive standard 1-2-1 at TRIZ step 1.7. The third material is introduced to prevent stiction between the elastic film and the valve seat. More specifically, the third material is coated on the surface of the valve seat to prevent stiction. According to the definition of IFR, valve opening function should be performed naturally without stiction at all times. Therefore, it is possible to consider IFR in which the valve is normally implemented without the valve seat, which is the cause of such stiction. And stepping back from this IFR, the idea of minimizing the width of the valve seat was created. At TRIZ step 5.1, concept solution number 9 was also created based on the inventive standard 1-2-1. The idea is to modify the elastic film to normalize the function of the micro valve. This is a concept to keep the valve open normally and to move the elastic film with pneumatic pressure when the valve is closed. At TRIZ step 5.2, analogy for problem solving could be applied. We thought about solving the physical contradiction defined in TRIZ part 3. And finally, it was found in the dumpling container at a decisive clue to separate the space, which is the operating zone of elastic film or valve seat. Steamed dumpling containers have thin plates with small holes in the bottom. These small holes are arranged tightly. There are contact and non-contact areas spatially separated in the thin plate. It makes it easy to separate the dumpling body from the sticky surface without damaging the dumpling skin. We came up with the idea to embody the tiny holes of this thin plate to the surface of the valve seat or the elastic thin film. This concept was also contributed to make the solution of physical contradiction. We tested some of these selected ideas through experiments. This slide shows the validation experiment for the valve seat with small holes like dumpling container thin plate. In 2011, Samsung Advanced Institute of Technology developed an initial model of IPCR system. This system was disclosed and manufactured as a diagnosis platform called GenSpector with the model name of TMC1000. This is a PCR chip with an idea to solve the microfluidic valve problem. And finally, the concept of the dumpling container steam plates was protected by an US patent in 2014. As a co-inventor, you can check my name. The second task relates to the performance of scanning optics on the IPCR system. Let's take a closer look at the scanning optics of the IPCR system. In this picture, you can see 4 micro chambers. For multiplexing scan, multiple chambers must be scanned for sufficient time. However, the longer the multiplexing scan time takes, the more PCR processing time is also delayed. Defining this problem situation as a contradiction makes the requirements clear. Once a contradiction has been defined, it is generally possible to find ideas and develop solutions by applying methods of resolving physical contradictions and inventive principles. However, we couldn't do that because there was a lack of understanding in the operation of scanning optics. So it was determined that the function-oriented search is the approach to find some clues. To the function-oriented search, we had to check again to requirements. These 2 requirements were made after the in-depth discussion based on contradiction. On this slide below, these are the key contents that make up the search formula. Thesis. A leading area was mainly in the field of optical systems and harvesting solar power technology. As a result, 7 patents were finally selected that could be used to solve the problem. Subsequently, 2 out of 7 were carefully examined whether they could be used. The first concept is based on one Korean patent. The core of this patent is that a cylinder lens and a micro lens array can be used to control the magnitude of the light. By adjusting L1, the size and local depth of the plane light could be adjusted. By introducing a cylindrical lens into an optical system, incident light can be made into a wide plane light. Therefore, the cylindrical lens was introduced into the existing scanning optics to increase the area of light focus. Accordingly, it can be said that the idea satisfies the first requirement. I'd like you to remind the first requirement as follows. The spot size of the focusing beam must be increased to get all the fluorescent dyes filled in the limited microchamber here. The second concept is related to the second requirement. The second requirement is that there should be no loss of light emitted from the luminescent and fluorescent dyes. The picture is a light reflector of a solar collector in another Korean patent. By using this patent, it was introduced that fine patterns such as Fresnel lenses and reflectors into the microchamber IPCR. This increased light collection and reflection efficiency to minimize light loss. As you see on this slide, the length of the longitudinal direction of the PCR chamber was increased with the cylindrical lens. After all, this not only speeds up the scanning, but also keeps the system performance. It can also be improved that the fluorescence information acquisition without any light loss by placing micro-optical patterns on PCR layers. Ideas based on function-oriented search were finally implemented in scanning optics. The right side picture. The last task was a mega project that included 2 challenges. The first was to forecast the future technologies of healthcare monitoring devices. And the second was to discover the innovative concepts of healthcare chip. Today's presentation will deliver only the core contents. To forecast the future technologies of healthcare monitoring devices, the most important thing we need to do was concerning the idea generation using multi-screen thinking analysis. Eventually, only the system part was remained as blank, which could be filled by interpolating technologies and ideas that logically match the upper system and lower system. Based on the development history of the technical system, as a result, the empty blank on the previous page was filled with ideas like this. Now, let's have a look at how the final result was brought into the world. It was developed under the name of Samsung S-Patch 3. Also, Samsung released it as an ECG diagnosis service product in 2020. ECG signal is a very important vital sign for monitoring human heart activities. There were so many contradictions in this project. While doing this, I applied for a total of 18 patents. Of course, most of them had good solutions using TRIZ. Now, let's talk about the challenges of healthcare chips. To approach this task, I had to look at op-amp because there were no healthcare chips in the world. And this op-amp was functionally most similar to the healthcare chip I sought. Op-amp means the operational amplifier, that is basic amp for amplifying the electric potential. It is very cheap electronic component commonly used in sound equipment such as speakers. Based on the structure of this simple op-amp, I thought about the trend of increasing system completeness as a guide for developing a perfect system. A complete system means that it is equipped with engine, control, transmission, and tool. But in case of op-amp, there were some missing subsystems, for instance, the control unit and transmission unit. So those decisions have been made in which filling some ideas in the currently empty subsystem, control unit, and transmission unit. Then these ideas were conceptualized. It was the final task to add some specific ideas with pink box and orange box to the existing system. Logic module functions to switch various biological signals so that they can be detected according to each situation. In addition, the communication module performs external data communication and records data. This concept has been protected by a patent. You can see my name in the list of inventors. A commercial product called Samsung Bioprocessor was released in 2015 based on this patented concept. Samsung Bioprocessor is an integrated chip that can detect various biological signals such as heart rate, GSR, PPG, and body temperature. The chip is also designed to be mounted on watch devices, mobile devices, and more. Now, let me show you the patents I have applied. The total number of patents created with TRIZ is 32. Besides, 31 fresh patents are being processed in our internal company's system. The 11 patterns highlighted in blue font are explained in details on my full text of my thesis. Finally, let me tell you about other TRIZ activities I am involved in. For the past decades or so, I have been organizing and operating Samsung TRIZ Symposium. This event started in 2011 and has been held quarterly. And every time, various TRIZ challenges are shared each other. About 100 developers and TRIZ enthusiasts are usually participating in this event. It's me. I can confidently say that it is the oldest and the most active developer conference in Samsung Electronics. I have also been doing various TRIZ activities by publishing presentation materials, papers, and some books. These are described in detail in the full text of my thesis. In conclusion, there are three main things I'd like to talk to, but I need to say that the first item only because the time limit. Why do I mention these three R&D projects? That's because these tests have a decisive influence on my in-depth understanding of the TRIZ methodology. The lesson from the first project is that I was able to get a clear picture of the TRIZ process, which has been understood in my mind only by theory. And of course, I became to know the Gen 3 TRIZ process is very useful and practical. Through the second task, I found that if someone has not knowledge at all about his own project, then function-oriented search will provide him with great insight. As you know, TRIZ is the knowledge-based problem-solving theory. I think that the function-oriented search is a really good tool that can make it expand the scope of the future TRIZ. And in the third task, I learned practically that technology forecasting and contradiction problem solving are closely linked. Thank you all for listening until the end. Many thanks to my scientific advisor, Dr. Andrei Efimov, and both official opponents. Thank you.
Thank you, Dr. Yero, for your great presentation. You are right on time.
Yes.
And okay, Oleg, what's next?
In the procedure, the next thing is a speech of the scientific advisor, and then speeches of two opponents. On behalf of scientific advisor Andrei Efimov, who cannot be here with us today, I will just read aloud his review. So Andrei Efimov is a TRIZ master, and actually he is working in the field, which is the technical field, which is close to Dr. Yo's field, biomedicine things. So I'm reading. First of all, Dr. Andrei Efimov pointed out the relevance of the work. The presented thesis reflects results of long-term successful efforts in a whole set of different TRIZ tools and entire TRIZ methodology application and practice in one of the most well-known and advanced innovative company, Samsung. So the main relevance of these results is in a very convincing and vivid high-level illustration of the practical value of TRIZ. The applicant demonstrates in detail the entire process, starting from problem statement and up to the problem solution by means of skilled application of technical and physical contradictions identification, function analysis, different tools, different trends of engineering systems evolution, function-oriented search, and other TRIZ tools. Main results include 4 items, as mentioned in the review. Healthcare monitoring device and chip development forecast resulted in creation of Samsung bioprocessor, which has currently been used widely in the biomedical devices, improvement in the polymerase chain reaction, scanning optics, and improvement of the microfluidic valve implemented in a diagnostic platform, GenSpector, created by Samsung, which is already in practical use. 39 R&D projects performed by the applicant with the use of different TRIZ tools. 36 patents issued to the applicant and 31 applications which are in the stage of internal patent examination. Practical value of results include solutions described in these documents, and they were implemented in real products well known on the market. This definitely indicates that the high level of these solutions and the entire practical value of this work. And even more, presented solutions were made in one of the most advanced and relevant Samsung R&D fields, healthcare, which amplifies their significance. Novelty. The novelty of described technical solutions obtained by the author is substantiated by the impressive set of patents issued in the USA, which are quoted in the text of the dissertation. We all heard this. And finally, the conclusion of Andrei Yefimov, recommendation. I believe that all materials presented by the applicants completely meet all the matriz requirements and regulations, and the applicant, Dr. Hyung-Seok Yo, deserves the rank of TRIZ Master. Signature, advisor, Andrei Yefimov, PhD, TRIZ Master, diploma number 81. Thank you. That's it. The next in the procedure is the speech of speeches of official opponents. And I would propose starting with in alphabetical order, and we'll start with Yuri Danilovsky. Yuri, are you here? Are you ready?
I'm here, Oleg. I have not so much reliable internet because we have deep evening. Maybe
gentlemen, just I'm sorry, because I see that there are two raised hands. Right among the participants. So since we do it the first time online, okay, the hands are gone right now. Okay, so please, rather than raising hands, if you want to say something, type it into a chat. I'm watching chat and I will react. Okay.
Actually, Valery, it was me who requested to raise the hand. It's easier to see who wants to ask something. It's very easy to go to the participants and raise a hand. Everything.
Yeah, but here it's also good when people type in and we can see. But of course, so what do we do? Do we have hands or we have?
But right now it's time for opponents.
Okay, so please wait, and then when we come to discussion, then you can raise the hands. Thank you. Sorry. Okay. Please go ahead.
Yula, go ahead.
If you not will be against, I will switch my video recording because during last session I had several interrupted of internet, and I worry about internet. Internet reliability. Okay.
You will play your video. Okay, that's fine.
Okay, then I will shut down the presentation.
Yeah.
Oleg, if you have my video, please share.
Okay, I will do that for you. Okay, let me do this.
Sergey, you have your hand raised, Sergey Kovenko.
That's right, because on request of Simon, yeah.
Yes. Thank you, Sergey.
Can you see the screen?
Yes, we do the screen.
Yeah.
On the topic of practical application of TRIZ in projects of Samsung.
Could you make it louder?
Very hard understandable.
Is it better?
Ni hao for every Chinese colleague, guten Tag for every
I don't understand it.
Not really. I don't understand it.
Chapter number 1, importance of the topic of the thesis. The work of the applicant contains detailed analysis of 3 out of 36 available patents for his inventions and 11 budget analysis, short analysis of the other problems solved by the applicants. All analyzed problems related to polymerized chain reaction, PCR. Project number 1, development of system on crystal microchip for analysis of signals of the surface of the human skin for purpose of health monitoring. Project number 2, improvement of an optical system for analyzing of fluorescence of microcells of biochips, which accelerated the analysis. Project number 3, improvement of microfluidic valve IPCR for a mobile device for monitoring parameters of human health, in which the problem of pusher sticking to membrane is solved. All 3 projects are related to fields that is at the intersection of microbiology, nanoelectronics, optics, and continuum mechanics, providing solving the most urgent problems that mankind faces in the context of COVID pandemics. These solutions are in the form of new diagnostic kits and hardware embedded into mobile phones and tablets. Next, chapter number 2, evaluation of novelty. The novelty of the technical solution obtained by the authors of substandard by the impressive set of US patents, which are quoted in the text on the thesis. 3 analyzed projects related to 2 important topics. Topic A, a device for health monitoring. The concepts proposed minimize the surface of electrodes that are attached to the patient's skin and reduce the noise level. Also, a technology for a chip-on crystal solution, single crystal version, as well as the device in itself proposed and implemented. Direction B, polymerized chain reaction, PCR, and the new technology for measuring parameters using a new optical system decreases the time of the analysis from 1 hour to 30 minutes without any loss in the quality of analysis. Chapter number 3, practical significance. There is 3 important sites in this chapter. Site A, for mankind, a device for health monitoring, and you can see link how it can made it. Microprocessor intended for health monitoring was produced as a brand of Samsung bioprocessor in 2015 and is currently extensively used in biomedical devices. The scanning optical system and improved microvalve described in the thesis were implemented in 2011 in the diagnostic platform for PCR Gen Spectre TMC 1000, that is the name of device. Sales of the devices for veterinary clinics started in 2012 through a specialized company, Junt Out Pharmaceutical. Side B, for the concern Samsung, in Korean language we say Chobol Samsung. Site C, for improving the status of professional of the inventor and the culture of the TRIZ. Generally, the higher number of talented engineers involved in TRIZ Via such impressive results, the better for our professional community of experts inventors. It is very important, colleagues. Chapter number 4, application of TRIZ tools. The thesis is rich in micro cases which can be used in the computerized TRIZ training system in the iSpark program, where 2,983 TRIZ cases from Samsung Electronics have already been described, and developers from different areas of technology are already looking at them. The opponent found examples of using of the following TRIZ tools in the thesis. First of all, function modeling, application of function-oriented search, main parameter of value analysis, application of 76 standards, cause-effect chain analysis, examples of formulated technical and physical contradiction, method of formulated ideal final result, and using the trends of engineering system evolution for forecasting of the evolutions of the system in the area of measuring human health parameters. All TESE tools were used by the authors correctly. Chapter number 5, criticism concerning the present work. Opponent's criticism is explicitly subjective. Such the facet of applicants and opponent coincide in terms of using of function-oriented search, while in the field of using of 76 standards, they do not coincident. Really, in the practice, very often I apply function-oriented search. One could complain about the fact that at such profusion of original content produced by the author, the use of 40 principles, and it's the most important solving tools for novices, but was used only in 3 descriptions. In transcribing the examples through the language of 40 principles was done in all examples in parallel of the ones which are already presented. It would increase the pedagogical value of the thesis. Not forget about teaching process also for new participants of the TRIZ. Final general conclusion. The applicant's tools, his trainings course in 2003, which means that they has been working as TRIZ expert for 18 years. The materials of the thesis include at least of 39 projects. The thesis included a detailed review of 3 most important patents and brief review of 11 more patents. The total number of patents granted to the applicants is 36. As the 31 patents applications are pending internal patent examination. Look at total amount, patent 67. The structure and content of the thesis meet the requirements of matrix regulations for TRIZ level 5, TRIZ master certification. Value of the work and high level of mastering TRIZ tools by Dr. Hyung Seok Yo does not cause any doubts. The quality of the thesis is high. The number of inventions, including implemented ones, made by Dr. Hyung Seok Yo using different TRIZ tools meets matrix requirements for a TRIZ master practitioner. Taking all the above into account, I consider Dr. Hyung Seok Yo to be a person who incontinently deserves the rank of TRIZ master. Opponent Yurinovsky, PhD TRIZ master, diploma number 82. Thank you very much for your attention.
Thank you, Yuri.
Hello, everybody. I am Yuri Yurinovsky. It is my opponent's.
Okay, so Yuri, thank you very much. Now it's turn for another opponent, Alexey Penyaev, who is also TRIZ master. Alexei, it's your turn now.
All right, very good. Can you hear me by any chance?
Yes.
Fantastic. Can you see my screen also?
Not yet.
Can see you.
All right, that's a good thing. I'm trying to share my screen here. All right, let's give it another try.
Yep.
All right, there we go.
Nice. Yeah.
Now we see it.
Fantastic. All right, let's go ahead and do it. I'm Alexei Pinyaev, TRIZ Master, Diploma number 70. Today, my function is to provide an opponent's review of Dr. Io's presentation, Dr. Io's thesis, TRIZ Master thesis, and I will be very happy to do so. So the first slide that you can see presents my key points. So I'm going to review some of the key thesis strengths. I'll talk a little bit about my opinion about thesis weaknesses. You will hear a bit of criticism there. And finally, come up with my conclusions. So let me talk a little bit about thesis strengths. So the first strengths I see in the work is that the work clearly stated and achieved the goals. Specifically, TRIZ prediction of development of healthcare monitor and chip via function analysis and multi-screen thinking was very successful. I was impressed by a part of the function analysis. I show it on the right-hand side of my slide, where definitely the project team, including Dr. Io, has discovered multiple harmful interactions between the skin and the patch. And definitely there was kind of a more like obvious path to, try to change the technology from contact to completely non-contact. The creative approach was to change it kind of midway to minimally contact, which I think is a very creative approach to solving this. So that was a great success and a great example of that TRIZ prediction part done with function analysis. Then the other example where the work achieved the goals is the use of function-oriented search to improve eye-PCR scanning optics. There are a couple of wonderful ideas that Dr. Io with his colleagues found when he was doing function-oriented search. And finally, a TRIZ was used to improve reliability of microfluidic valve. And there are many interesting solutions offered and patented by the project team. The other strength of the dissertation is there are elements of TRIZ novelty in the work. I am not sharing necessarily an opinion that the novelty of the practitioner's master dissertation has to be only in the patents. I believe that TRIZ masters, practitioners, must have some TRIZ novelty, something new that they bring into TRIZ as a field. It will not be development of new methodology, otherwise it will not be a practitioner's thesis, it would be a methodologist's thesis. But the way for novelty for practitioners, in my opinion, is to use existing TRIZ tools in new ways. And I found a wonderful example of that in Dr. Io's presentation. And this is where he uses multi-screen thinking for development of requirements to his healthcare monitor. Usually we use multi-screen thinking with existing system. We have the system, we define super system, subsystem, systems past, systems future, but this is all based on existing system. Dr. Io actually has shown pretty convincingly how to use multi-screen thinking for the system which does not yet exist, which is, I think, well, I'll hesitate to call it a breakthrough, but it's definitely a very good example of a known TRIZ tool used in a new, unusual, and interesting way. So there is some TRIZ novelty right there on the spot, which kind of confirms Dr. Io's mastery of using TRIZ tools. Not only use them correctly, but also use them in a masterful, new, and unobvious ways. Finally, work, as mentioned before by previous opponent, has significant practical value. Remote monitoring of key vital signs, such as heart activity and blood pressure in people via wearable sensors with minimal contact. Very helpful, very useful. Lots of people benefited. In use of, Samsung developed cancer diagnosis, drug development, drug genetics tool, IPCR system, definitely benefited a lot of people as well. So definitely a lot of practical value, protected by patents, but also most importantly, actually put on the market into people's hands in helping people. So lots of practical value. Now let's talk a little bit about what I believe are weaknesses of the thesis. So the first one, I believe, is that I call it easy inventions. The inventions that were made by TRIZ, but could equally well be made by non-TRIZ methods as well. Morphological analysis, brainstorming, that sort of things. So in particular, I don't believe that Dr. Io's use of the trend of the technical system completeness provided significant competitive advantage as compared to non-TRIZ methods, such as staying current with the trends in the industry. I don't think it really offered any significant advantage. So other companies were developing similar type of devices, like think about it, Apple Watch, Google glasses and stuff like that. So there were lots of trends in the industry that, people could just watch and make similar kind of decisions based on, studying on what's out there, which Dr. Io has also done, of course. So the use of TRIZ tool here was helpful to Dr. Io, but similar things could be done without TRIZ, I believe. So for microfluidic valve, in my opinion, the cause and effect chain analysis that was done by Dr. Io in the project group was pretty much a standard root cause analysis. I did not find there anything specific to TRIZ or any insights that I could attribute to specific use of TRIZ thinking. TRIZ cause and effect chain analysis is different from root cause analysis. Oleg Abramov extensively wrote about it. So I suggest Dr. Io to go back to those references and understand the differences. But I believe it was pretty much a standard RCA. Also, the ideas that were produced on improving reliability of microfluidic valve took a careful look at the ideas, lots of good, interesting output. But I believe that similar ideas could be produced in a brainstorming session. So there was nothing, I did not see a very clear link between arrays, tools, physical contradiction, ideal final result, use of resources. I did not see a good, solid link between those tools and the ideas. So the ideas are pretty much, the kind of crop that you get from brainstorming, my understanding of that. So that's one area where I think the thesis could have been better. The other area where improvement could happen is that give us more good TRIZ examples. And when I say good example, I mean, give us examples that really require using of TRIZ to come up with those ideas. It would not be possible to come up with those ideas without TRIZ. I found 3 of those strong examples in the dissertation. The use of multi-screen thinking, as I mentioned, for defining requirements to a new system. functional analysis for health monitor, and using of function-oriented search for IPCR screening optics. I believe that master dissertation should have more than 3. I personally would be happy with 5, but it's just my personal opinion. It's open for discussion. My conclusions here, I do recommend Dr. Io's work for defense. And I also believe strongly, based on my analysis of his thesis, that his work meets TRIZ requirements for TRIZ master qualification. Thank you.
Thank you.
Okay, thank you very much for 2 opponents. And now it's time for questions and answers from the panelists. Again, you can raise your hand in the participant window or put it in chat that you want some questions. I already saw 2 hands from Dr. Sergey Aikovenko and Alex Lubomirsky, and Sergey. Okay, Victor Fay as well. Okay, Sergey, you were first, please.
Yeah. All right. I have 2 simple questions. Thank you very much, Dr. Io. I was impressed, and I don't question the validity and the importance of the inventions. They are really great, though I cannot say I understood kind of everything, but so I just focused on the TRIZ tools that you used, because, just these days I look through hundreds of ARIZ projects. Now I dream about ARIZ at night. So I was very excited to read that the TRIZ activities and dissertation really gave you very deep insights of ARIZ. However, what I saw there, I didn't see ARIZ. I saw technical contradictions of the key problem. I saw step 1.7, that is modeling this problem as substance field model. Then I saw ideal final result that is really not connected with the resources. And then part number 5, when we use different TRIZ tools, including function-oriented search. So the major thing, the heart of ARIZ is basically formulating new physical contradiction about the resources. So we formulate the resources, and they give us, take a resource as this X factor, and it helps us to formulate new physical contradiction about these resources. And I did not see that at all. So just separate parts of ARIZ that do not really make ARIZ. The most important part is missing. So maybe, it was not included in the dissertation, but I did not see it there. So I would like to hear your comments on that. That is the first question. And the second question, just to shut up, there is the slide, it was, what is something? There was a slide with an S-curve in your forecast project. So as you know, S-curve, it is time, and the vertical axis is MPV, right? And a very important parameter. I wonder what MPV, your vertical axis of that S-curve means.
Dr. Io, please answer 2 questions. First, about the application of ARIZ.
Okay. For first question, unfortunately, we couldn't do process to find new physical contradiction because at that time we thought about the first physical contradiction is already cleared. So first of all, based on first physical contradiction, once we start, and after there's anything something strange or something really bad situation that we didn't control, at that time we we think we are going to find another new contradiction, new physical contradiction. But I agree with you, Dr. Ikobenko. Unfortunately, we couldn't try to find new physical contradiction. I agree with you. Yeah.
So it's not a RIZ. Basically, it's modeling the problem as technical contradiction, physical contradiction, and substance.
That's right. Yeah.
Thank you.
I have already learned from you lecture.
Remember how much time.
Thank you, guys. Let's keep timing. Dr. Yeo, the second question was about the vertical axis of your S-curve chart. It's funny that I had exactly the same question. It's, I believe, slide 28 with S-curve. What is on vertical axis here?
Wait a minute, please. Slide number 28.
I believe it's 28. The slide with S-curve.
S-curve. Yes.
In the presentation, just many technology.
Based on MST healthcare monitoring devices, right?
Yeah, you have a slide with
only one.
Okay. I see. Yeah. In this case, we have to find the new idea. So we have to apply the trends of evolution, and some other say that the S-curve means that of course the find some prediction. If we can define the current time as 4 stage of S-curve, one of them, for instance, if this current is the second phase, yeah.
저기에서 그 Y축에 그 S 커브 그린 데서
네네네.
MPV가 뭐냐고 그 핵심 MPV가 그게 뭐냐고.
Y축에
Professor Song.
예.
그 뭐냐고.
여기서는 그 Y축의 MPV가 뭐냐면 그 성능이라고 보면 되는데요. 성능이라고 보면 되는데, 퍼포먼스인데 그 퍼포먼스를 저희는 어떻게 정의를 했냐면 사용자가 얼마나 편하게 느끼느냐, 편의성과 그 다음에 얼마나 측정의 정확성이 보장되느냐, 이 2가지라고 보시면 되겠습니다. 일단 성능이고요. 첫째는 그 성능 안에서 2가지로 분기되면 편의성과 측정의 정확성이다. 이렇게 정의할 수 있습니다.
He said the main MPV is performance. He explained what is performance. Performance is the convenience for customers, for users, and accuracy of
measurement,
yeah.
Detection. Yeah.
So how did you measure it? What the deviation, or how did you measure customer convenience? If I want to build this S-curve with numbers.
Convenience relates to the contact area between human skin and electrode, and the measurement accuracy of measurement relates to the noise, moving noise. If someone have active noise, dynamic range, depending on this various noise, those noise being introduced in the system. So we have to reduce the level of noise. Understand?
So you mean, you understand? Yeah, my understanding is that for both MPVs, that these solutions are the same stages of the S-curve. Am I right? How can you calculate average MPV, between the area of the skin and the noise?
I'm sorry, dear members of TRIZ Master Certification Council. Time is important. Please make your questions shorter, and Dr. Yer, please try to address the question in the shortest way as possible. But we, Oleg Abramov, we forgot one thing that before maybe questions and answers, there is a person here, the Matriz president, Dr. Oleg Feginson, who worked with Dr. Yer for many years. And due to the fact that the scientific advisor, Dr. Yefimov, cannot participate, maybe Oleg Feginson, could you just share a couple of words? You know Dr. Yer for many years, just to be as short as possible, but please.
Of course, Simon, thank you very much for the opportunity. Many years, well, since 2014, I met Dr. Yo and we participated in some common projects. And I can tell you one thing which may convince TMCC. You know, many people in Samsung Electronics, they are TRIZ managers. Dr. Yo is not like that. He's a problem solver. That's what I want to add, to be short.
Okay, it's very short and very important.
Thank you, Oleg.
Thank you very much, Oleg. Okay, the next question, or maybe set of questions, knowing Alex Lubomirsky. Alex, you were the second.
Yeah. Okay, first of all, I would like to emphasize that I was really impressed with this development and, you know, practical results and high tech. You know, it's difficult to do something in this area. And after that, questions. You claim that you made prediction, made forecast how this technology will be developed in the future. What trends of engineering system evolution did you use for this forecast, Dr. Yeo?
송 박사님, 제가 한국말을 좀 해석 좀 해주시겠어요? 제가 영어가 짧아서.
In English, please.
Yeah. I'm sorry, Dr. Song. Now I'm asking the translation, Dr. Song. 예, 저는 그 기술 예측에 대해서, 테크놀로지 포캐스팅에 대해서 지금 하는 게 어떤 생각을 하고 있냐면.
거기 퀘스천은 지금 첫 번째 아까 그 문제를 푼 거 중에서 어떤 그 법칙을 사용했느냐가 저 사람의 질문이거든요.
네네네네. 그 테크놀로지 포캐스팅 했던 과제가 이제 말씀드렸던 대로 2개 과제인데, 첫 번째가 이제 그 헬스케어 모니터링 디바이스고, 두 번째가 헬스케어 칩이죠. 그런데 제가 이제 그 질문에 맞추어서
project according to the healthcare
monitoring device and
chip. device and the chip.
예. 근데 그 두 개 중에서 좀 강조점을 두어서 말씀드리고 싶은 게 칩 부분이에요. 헬스케어 칩.
He wants to stress project with 헬스케어 chip.
예. 헬스케어 칩이 아까 제가 발표에서도 말씀을 드렸지만 세상에 존재하지 않았었어요, 그때는.
There is an alternative in the world. There is no alternative in the world at that time.
그래서
I'm sorry for interrupting, guys. There was a very specific and short question. Please answer in the shortest way. Alex Lubomirsky is asking, what specific the trend did you use? Just list 1 or 2 or 3 trends.
Okay.
That's it.
예. 답변을 드리면
완전성의 법칙 사용했다 그랬잖아요.
예, 시스템 완전성의 법칙을 사용했죠.
He used the trend of technical system completeness.
Okay, good. Anything else? Any other trend?
다른 것도 사용한 거 있어요?
그게 메인이었고요. 그 다음에 그게 중심이 돼서 이제 주로 저희는 이제 역동성을 증가하는 쪽으로 많이 생각을 했었죠. 역동성 증가.
Increase of
Dynamization.
Dynamization.
right.
Okay.
Thank you.
Okay. Thank you very much, Alex. Any other questions?
Nothing more. It means that actually, forecast is a quite complex methodology. And if we apply just one trend or just, by the way, I didn't see this trend of increasing dynamization in this development. I saw only a trend of increasing completeness. If we use one or just two trends, the reliability of such prediction is quite minuscule. We should apply.
Alex, I'm sorry for interrupting, but let me add one more thing. This person has only 25 minutes. Believe me, he knows all trends.
Well, but but I cannot see results of his knowledge in this development.
Alex Lubomirsky, there are some other trends in the thesis. Not everything was in the presentation. The short answer is
I didn't see them there. Okay,
yeah, I'm sorry. I'm sorry, Alex.
Can I add one small question on this subject?
Sure.
Yes.
So when you use the trend of technical system completeness, you said there was no transmission and the control system at that time. How did a system could not have a transmission when they have engine and control system?
예. 제가 요거는 한국말로 좀 할게요. 그 숙제가 뭐였냐면 헬스케어 칩을 어떻게 설계할 거냐였는데 정작 헬스케어 칩이라는 자체가 존재하지 않았어요. 그래서 헬스케어 칩과 가장 유사한 게 뭐냐, 그 조상이 뭐냐를 찾았더니 그게 OP앰프라는 걸 저희가 결론을 내렸어요. 아주 간단한 앰프죠, 말하자면. 그러니까 그냥 그 일렉트릭 포텐셜을 증폭시키는 우리 그 스피커에 쓰는 그 증폭기 앰프, 그 OP앰프 칩이죠. 그래서 그 칩을 가지고 분석을 하자 해서 봤더니 그 칩이 전원이 들어오는 부분하고 전원을 증폭하는 부분하고 이렇게만 딱 구분이 된다는 걸 저희가 이제 딱 정리를 한 거죠. 그럼 그걸 어떻게 정리할 수 있느냐? 전원이 들어오는
어떻게 컨트롤 시스템
없죠, 그러니까
없이 바로.
그러니까 전원이 들어와서 증폭이 되져 나가고 그래서 그거를 작동부하고 구동부로만 저희가 본 거예요. 거기 제어부하고 전달부는 없는 거죠. 그 OP앰프에는. 예. 그래서 그거를 기준으로 우리가 이 OP앰프가 장래에 헬스케어 칩이 될 거라고 가정을 하면 OP앰프에서 출발하자. 그러면 OP앰프에 비어 있는 전달계와 제어계를 어떻게 채울 것인가. 이게 아이디어를 만드는 키가 되지 않겠느냐. 이렇게 아이디어 개발 발전의 방향성을 잡은 거죠.
Okay, dear colleagues, again, please be more short in your questions and your answers. we cannot make it like 7 hours.
I'm sorry.
We have maximum 2 minutes for.
Okay, Alex, any other questions, or I can ask?
Just I have questions. Look, as a TRIZ master practitioner, you should demonstrate that you can use all existing TRIZ tools. But in all these cases, we saw just very limited number of applied tools. For example, we didn't see trimming, flow analysis, super effect analysis, clone problem applications, feature transfer. We didn't see how you apply methodology for improvement of technological processes. Right? May I ask you, just very briefly, provide us example from one of these number of patents where you applied, let's say, trimming of technological processes.
Alex, sorry, let me address this question. In the regulations, it's not required to demonstrate all TRIZ tools in
It's correct.
the...
But I have very specific question. Would you provide a very brief example how you somewhere applied, let's say, trimming?
Yes,
Very
I
brief.
have. Yeah, I have one example for using trimming, kind of. Washing machine patent. Yeah. That's right.
And
That's
okay,
all.
explain us what component was trimmed. No, in your, remember, I don't need the training examples. I am talking about in your experience.
Yeah.
Did you apply trimming in one of your patents, your project?
Yeah.
특허에 그 트리밍한 거 있어요? 특허에?
예, 트림한 거 있죠. 그 세탁기에서 앞에 도어 부분에 그
특허 번호가 몇 번이에요? 그걸 가르쳐 달라니까.
특허 번호요.
요번에 프레젠테이션 특허가 있는 거죠?
그쵸. 그 목록이 30개 몇 개가 있는데 이 발표 자료에는
Anyway,
언급이 안 돼 있고.
He said that there is the patent about trimming project. Yeah, actually he got patents using trimming.
Very good. Tell us. Just
I can tell you, Alex, I can tell you if you will. That was the project which I was involved in. So we trimmed 1 gram of the washing machine. What they call in English, in Korean, I'm sorry. So that was a case when LG produced a product with the 2nd drum of washing machine, and Dr. Yo was leading the project where the 2nd drum was trimmed and door of the washing machine was used as a drum.
Great. Yeah,
okay. It would
I
be
like
nice
the
if Dr. Yo would explain it. Okay.
But again, Alex,
Alex, excuse me. You know, all Korean people, believe me, they are shy. They don't want
no
to,
questions, Oleg, please.
Okay.
Just and my impression, I would like to repeat what
are
Alex.
Are you satisfied with my answer?
Yes,
okay.
I satisfied.
Oleg Ferguson. Guys, let's continue. Alex, your time is...
Just a few more words. Just what I observed, and I agree with Alex Penyaev. We saw a number of TRIZ tools like function analysis, cause and effect chain analysis, and so on, but there are no links, there are no correlation between them. It looks like they are kind of just function analysis separately, cause and effect chain analysis separately, and problem solving separately. It is not a kind of the process. It's like ritual.
Okay, Alex, thank you. It's not a
Simon, sorry, I have just very quick comment, okay? Alex, you are absolutely right, but now we have only 25 minutes for the presentation of the candidate. Believe me.
Thank you.
Dr. Yo has all these links.
Okay, guys, sorry, thank you very much. Anybody else out of the list of panelists? Victor Fey, did you have a question?
Yes, I did.
Yes, please.
Actually, originally I had 3 questions, but 2 first questions were asked by Sergey Ikovenko. Thank you, Sergey. So I have just one little question. In your analysis of your optical scanning technology using arrays, you mentioned that you formulated a physical contradiction which you couldn't resolve. And then you applied function-oriented search to find the solution, which effectively means that the physical contradiction was resolved. So I have a question: why couldn't you resolve? Why couldn't you resolve it in the first place? In other words, what prevented you from what methodological hurdle prevented you from resolving this physical contradiction? So you had to resort to function-oriented search. Thank you.
function-oriented search에서 contradiction을 어떻게 해결한 모습이 안 보인다 이런 지금 질문이신 것 같은데 이 과제 이 두 번째 과제에서는 사실은 이 피지컬 컨트라딕션이 requirement를 분석하는 목적으로가 많이 쓰였습니다. 그러니까 I think that I understand your question. In case of second project concerning the function-oriented search, in case of this project, the contradiction, physical contradiction is used by just find some requirement, just requirement. Of course, we wanted to solve the we wanted to find some solution for a physical contradiction, but we don't have any knowledge at all our own project. So we have to analyze more detail the scanning optics. Not important some kind of situation.
Dr. Yeo, let me elaborate a little bit. It also coincides with Professor Song's question he wrote in chat. If you're using function-oriented search, first of all, there is your domain expertise. You are dealing with optics, and you are saying that you have you didn't know about optical lenses.
That's right.
It's pretty strange. That it's why do you need the function-oriented search to bring the solution from your area of expertise? Usually, function-oriented search is used to bring non-trivial solutions from some other areas called leading areas, which are functionally similar but far from your initial area. But you formulated a problem in optical area and brought a solution from optical area. Why do we need function-oriented search?
Yeah, because we don't have any clue to. We don't understand the optical system. We don't have any knowledge concerning the optics. So at the beginning stage, we have to find some optics knowledge. So we have to start with function-oriented search. So we have
the beauty of function-oriented search is that you generalize the function, going get rid of the specifics of the functions that you are dealing with and looking for solutions, functionally similar solutions in some other areas. But you found the solution in a very close area.
I see. Of course, I agree with you. But the result of the search provided us the kind of optical field and solar system field. So
I see.
I agree with you.
Thank you. Guys, we are out of time.
One quick comment. Solar field energy, harvesting is a totally different area.
Okay, it's different. Yeah, I got it from the answer of Dr. Yeo. Dear members of the TRIZ Master Certification Council, is there any other question from your side?
Yuri Bielsky has a question.
Yuri Bielsky, please.
Thank you, Simon. Dr. Yeo, thank you very much for your interesting presentation, and you certainly have impressive number of patents. I wish to ask you a question from an academic side. I spent the last 25 years at university, and I'm a little concerned on your contributions to the patents you listed. Say, in academia, there are three options of how the authors are listed. The very old one is alphabetical. And the newer one is the first author is actually the person who probably contributed about 80% or more to the paper. And the last person usually is the person who is a research leader. Now, in the two patents you've listed on microfluidics, for example, device, it's first of all, it's not very many patents, then you are the first author. And the two which you specifically listed, both in abstract and in your thesis, in the microfluidics device, you are number 5 of 5 authors. And in the biosignals, number 5 of 8 authors. Would you comment, what's the way the authorship is done for patent authorship is done at Samsung, and what specifically is your contribution?
I see I see your comment. As I had worked as researcher or developer, I can make it my role, play a role, my first author, but after changing my role as a consultant, Samsung's rule make it the first author must be developer, not consultant. So I cannot help saying my role as consultants right. So that's all.
We have a comment from Mr. N. He's writing that in Korea, an in-house consulting case, the methodology consultant is placed the last in the patent authors list. It's an internal rule of Samsung. That's just the internal rule.
Well, thank you very much, Dr. Yeo, and thank you, Simon. It was a very good answer, and I hope that the question clarified and the answer clarified quite many things.
Okay, thank you. Thank you. Okay, Oleg Abramov, I believe we're completely out of time.
Absolutely.
We should close this session. First of all, thank you very much, everybody, all the panelists, for your active participation. Me personally, I have a couple of more questions to Dr. Yeo, but I will stop myself. And just a very quick comment, Dr. Yeo, you use the function to separate in your function analysis. Just think about what the definition of function is, the action that is changing or can keep the parameter of object, and what the action separate, what parameter is changed. Just think about it. Okay, Oleg, let's follow the procedure.
So the procedure is we need to vote first, and this time we will be voting online using Slido system, and everyone, I guess, received the link for that. After that, I think we need to approve the results of the TMCC session by Matriz board.
Yeah, that is exactly correct. So
and
I
then
need
we will
to
announce them, and we have
10
10 minutes for everything.
I have a question.
Yes.
So now you vote, then I should connect all Presidium members and approve your voting results, right?
Not voting results. The role of Presidium is just to check whether the procedure was correct, or whether any serious violations of the regulations. I mean, the serious that could affect the results of voting. That's the role of the Presidium, not to check.
Right. Yeah, I understand that, Simon. Thank you very much for clarification. Please go ahead with voting, and then I will connect the board members for approval.
Okay, guys, you got from Valery Sushkov the TMCC vote link. Let's do it right now. please.
Yes. 3 minutes for voting, let's say, and then go on Skype. Good?
Yep.
Okay, so I'm muting my...
So we're leaving this meeting?
No, I would prefer to stay on this meeting.
We would
Mute
stay.
your microphone and camera and vote.
Sorry, where did Valerie?
Where did the link?
sent
Yeah.
us the link?
He sent it on email.
Yeah. We need to check email.
Yes, please check your
I
emails.
got it. Yeah.
Oh, you sent it on the other mail. Okay.
It's normal mail.
Well, if someone is having a problem, please tell me. Because this is completely anonymous voting, and I cannot see who is voting, who is there. So,
Okay, Valerie,
Valerie,
I voted.
Valerie Suskov.
6
you
persons vote.
Valerie,
Yes.
please give me the results of voting, and then I will connect board members in this.
Well, actually, I will show the screen.
All right.
So everybody sees.
I did. Yeah.
8 persons. We have 11 people. Now we have 8 votes.
Actually, we have a virtual accounting board.
Yes, we have a virtual return board.
Yeah.
Here we go.
9 persons voted.
Okay, I found it. It worked. So thank you.
So 2 persons more.
Okay.
So 1 person left.
And then somebody should announce the results, and then board should approve these results.
Correct.
Well, I can show the screen, but we still miss 1 person.
1 person?
Yeah.
This person.
Yeah. 1 person is missing.
Oleg, you have the...
Yes, I do.
You can see it too.
Yeah. 1 person did not vote.
We cannot see who, unfortunately.
Okay, it's anonymous voting. All right.
Yes.
You cannot see who.
Well,
we can wait for another 30 seconds, but if this person is not voting,
no, at least we have
quorum. We have quorum.
The result is clear. So
yeah. By the way, it does not have option of
that's
staying.
right.
Yeah.
So shall I show the results?
You certainly can consider 1 vote as wrong because it's clear that the vote is clear.
I agree with you, Yuri. Please go ahead, Valeria. Share the screen.
Okay. Where is this? Okay, now we can see the screen.
Yeah.
Good.
Okay.
Done.
10 votes and
9-4, 1 against.
Okay, 9-1. Okay, the results are clear. It's positive, and now we need only formal approval from the TRIZ Presidium, and then we can congratulate Dr. Yeo.
Thank you. Thank you so much.
Thank you, gentlemen.
Oleg Figinson, now it's your call.
Absolutely. So please stay online.
Okay.
Do not disconnect Zoom. I will switch my mic off and call to the Presidium members in other.
Oleg,
Okay.
Oleg, you have 4 minutes until tomorrow.
Thank you very much, Yuri, for the reminding.
Yuri Bilski, what is your time in Australia right now?
As I said, 4 minutes tomorrow.
I believe you were talking about Korea. But it's
No. We left it at 1 hour.
Okay. Now you in Australia will have submarines from the United States and Britain.
You never know. It means it's a couple of years ago, we were entirely certain that it'll be French, not Japanese. Now it is about American and English, but who knows? Maybe in 3 years, politicians will change their opinions.
Yeah, I personally was very surprised that it was abruptly changed from France.
Excuse me. I would ask people in the room to be a little bit quiet because we need to make an approval.
Okay, sorry.
If I switch my Zoom, you all will be gone. I'm sorry.
Okay.
I cannot speak on Skype.
I don't have much to discuss. I guess most of the people from the board are there in TMCC. So do you agree with the decision of TMCC?
Yeah.
Yes.
Yes. Yes.
All right. Thank you very much, gentlemen. So I will switch off Skype and then I will announce that in Zoom.
Yes.
Good. Wait a minute for me to join once again.
Yeah.
Actually, we already heard Oleg Faginson. It was not anonymous. Okay,
Next
but
time we will improve it.
yeah. You should, Valerie, separate these two things.
I try
You know
to do
what
my
happened,
best.
Simon? Many people didn't mute their microphones.
I see.
Anyway,
Okay.
so be as it may, the board of Matriz has approved the decision of TMCC. Congratulations to Dr. Yo. You are now a TRIZ master. Simon, the stage is yours. Please.
Okay,
say
but I will spend just 30 seconds. Dr. Yer, my personal congratulations from the entire Council of TRIZ Master Certification. You are now an official TRIZ Master practitioner. You will get your diploma by mail from the executive director of Matriz. Thank you for your hard work and dedication, and thank you all panelists for your active participation.
So congratulations from Germany.
Thank you. Thank you all. Thank you all. Thank you, gentlemen.
Congratulations from Korea. Great job.
Congratulations, Dr. Yo.
We have a new TRIZ master in Korea.
Thank you. I appreciate it. Thank you. Thank you so much.
You're welcome.
Congratulations.
Thank you, everyone. And it was great to see everyone, at least virtually. And now I send you
it's time.
a good night from tomorrow.
Bilski, you know this joke regarding the COVID that from tomorrow the postman will work online. He will read your letters and will inform you if something is important.
It's more or less how it works now.
Okay, guys.
I was happy to see you personally. Korean expression, long time no see.
Okay, guys.
And looking forward for a beer when we can rejoin in person again.
Okay.
That's the next conference.
Guys, I announced that this session of TRIZ Master Certification Council is completed. Thank you very much and see you
in a minute. We are continuing with the conference.
Okay.
I mean, you invite us to come? Valery, is it what you are saying?
Well, everybody knows. Everybody
it's quite dangerous. But, and what are the regulations in the Netherlands? It means how many people can attend?
No regulations at all. We are.
Oh, wow, really?
It's Netherlands. We are free.
Okay, thank you very much, everybody.
Okay. Anyway, thank you.
Thank you so much, gentlemen.
Thank you.
Thank you. Dr. Yeo, once again.
Ladies and gentlemen,
감사합니다, 성 박사님, 성 교수님, 감사합니다.
네, 고맙습니다.
Please,
congratulations again. Take care. Bye-bye.
Please use another link to join our next section of the conference. Thank you very much. Bye-bye.
Thank you so much.
Thank you, bye.